Hello, ladies and gentlemen, it's me back again, Cracker, and today we're gonna be talking about what is networking. Uh, it's gonna be the fundamentals about networking. It's not gonna be all of this. We're gonna be talking about some data communication, connectivity, network infrastructure, network security, and scalability and performance. We're not going to be going into depth of any of these. There's some descriptions I found for each one of these. This is not my work, but yeah, I just found it and put it there. If you want to read it, this is the sort descriptions of them. We're going to be using Trey Hackman again. We're still in the pre-security course. And if you haven't watched my other videos, I've been going to introduction to cybersecurity. And now we're in the network fundamentals. So we're gonna be going on what is networking. There is a video on it. If you want to watch that one, you're welcome to. I'm also doing this video. If you want to watch mine, that's perfect. So yeah, let's get right into it. So networks are simply things connected. For example, your friendship circle, you're all connected because of similar hobbies, skills, and sorts. Networks can be found in all walks of life. A city public transportation system, infrastructure such as the national power grid for electricity, meeting and greeting your neighbors, postal systems for sending letters and parcels. But more specifically, in computer networking, the same idea just dispersed to technology devices. Take your phone as an example, the reason you have access to things. We'll cover how these devices communicate with each other and the rules follow that follow. Now, this is trying to give you some similar examples to networking, but we're gonna be working with networking from emails. So there is mails and emails. Uh, which mails are physical mail, and then emails are electronic emails. But yeah, it's like Gmail. So in computing, a network can be formed by anywhere from two devices to billions. These devices include everything from your laptop and phone security cameras, traffic lights, and even farming. Networks are integrated into our everyday life, be it gathering data for weather, delivering electricity to homes, or even determining who has the right of way to a road. Because networks are so embedded in the modern day, networking is an essential concept to grasp in cybersecurity. Take the diagram below as an example. Alice, Bob, and Jean have formed their network. We'll come back on this later. So if you see, Alice can message Bob, and Alice can message Jim, and it's a triangle. Uh, yeah. No. Networks come in all shapes and sizes, which is something that we'll come on to discuss throughout this module. What is the key term for devices that are connected together? That would be network. There you go. What is internet? Now that we learned what a network is and how one is defined in computing, just devices connected, let's explore the internet. The internet is one giant network that consists of many, many small networks within itself. Using our example from a previous task, let's now imagine that Alice made some new friends, named Zion and Toby, that she wants to introduce to Bob and Jim. The problem is Alice is the only one person who speaks the same language as Zane and Toby, so Alice have to be the messenger. So if you see Zane sends a message to Alice. Alice can send a message to Bob. Bob can send a message to Jim. Jim can send it to Alice, and it can go back. Or Toby, and then it can form that circle. Now this is a bit inefficient because she's a middleman, but yeah. Because Alice can speak both languages, they can communicate to one another through Alice, forming a network, a network. Oh my God, forming a new network. The first iteration of the Internet was within the ARPANET project in the late 1960s. This project was founded by the United States Defense Department and was the first documented network in action. That would be the World Wide Web. However, it wasn't until 1986 when the internet, as we know, it was invented by Tim Berners-Lee by the creation of World Wide Web. It wasn't until this point that the internet started be used as a repository for storing and sharing information just like it today. Let's relate Alice's network of friends to computing devices. The internet looks like a much larger version of this sort of diagram. So yeah, this very basic diagram, but you can see this is the internet. This could be the server or the network. It will be the server going to the computer, going to the internet, and this is how they access it. This should be your router technically, not really, because then the router goes to the company that you're used to, like T-Mobile or something like that, and then it goes to the internet. But very basic diagram. So yeah, as previously stated, the internet is made up of many small networks all joined together. These small networks are called private networks, where networks connecting these small networks are called public networks, or the internet. So to recap, a network can be one of two types: a private network, and a public network. Devices will use a set of labels to identify themselves on a network, which will come onto it in the task below. Who invented the World Wide Web? That would be, if I'm spelling it correctly, Tim Berners-Lee, like that. Yes. Okay. 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 So, identifying devices on a network. To communicate and maintaining order, devices must be both identifiable and identifiable on a network. What use is it for if you don't know whom you're talking to at the end of the day? Basically meaning if you're not talking to the person you want to talk to, then what's the point of it? Devices on the network are very similar to humans in the fact that we have two ways of being identified: our name, our fingerprints. Now, this what's gonna go on is that we can change our name, but we can't change our fingerprints, which I would disagree a little bit. We can technically change your fingerprints, but it's very painful. And same with an IP address. You can change your IP address, but you can't change your MAC address, which that would be your fingerprints in it online. But you can also, again, spoof it. So yeah, this is what it basically says here. We can actually, now we can change their name though, date poll, but we can't however change their fingerprints. Every human has an individual set of fingerprints, which means that even if they change their name, there's still an identity behind it. Devices have the same thing, two means of identification, with one being permeable. These are an IP address, which again, name and media control access, or MAC address, or fingerprints. Now, uh, if you go to your phone settings, thing Wi-Fi, and then the information, you should have your IP address right there. So usually it starts with 10.0, like yeah 10 oh 10 point 10 point 10 point 10 point, and that could range from 0 to 255. Usually IP address start with I think 198 or 196. Anyways, we're gonna be talking, yeah, 192. Well, it's right here. 192, 168, 1.1.1. And yeah, you can range from 0 to 255. Briefly, an IP address or the Internet Protocol address can be used as a way of identifying a host on a network for a period of time, where the IP address can be associated with another device without the IP address changing. First, let's split up precisely what an IP address is in the diagram below. Now you can see they have different octets, which we're going to be talking about later on. And these can be ranging from 0 to 255, and this is usually a Wi-Fi network. And yeah, An IP address is a set of numbers that are divided into four octets. The value of each octet will summarize to be an IP address of the devices on the network. This number is calculated through a technique known as IP addressing and subnetting. Also, you can see you can find your subnet in your phone settings if you go to your Wi-Fi, then click more information or the I symbol, and yeah, you should be able to see that. But that is for another day. What's important to understand is here is the IP address can change from device to device, but cannot be activated simultaneously more than once within the same network. So you cannot have the same IP address on the same network. IP addresses follow. Now, when I say the same network, I mean, say you're at your house, and then your phone and your brother's phone are both connected. uh, those phones will have a different IP address. Now it could be 192.168.1, and then yours could be 55, and your brother's could be 56. That's a way to look at it. IP addresses follow a set of standards known as protocols. These protocols are the backbone of networking force many devices to communicate in the same language, which is something that we'll come onto another time. However, we should recall that devices can be both private and public network. Depending on where they are will determine what type of IP address have a public or a private IP address. A public address is used to identify the device on the internet, whereas a private address is used to identify the device amongst other devices. Take the tablet and screenshot below as an example. We have two devices on a private network. Now you can see just from the IP address, you can just see that this is private and the 86 is most likely public. And again, you can just tell. And these two technically can be on the same network because you can see they're pretty similar. Also, these two can also be on the same network. As you can see, they're the exact same one because it's public. Everybody is using it. Uh, it's a lot to go onto right now, but just know that. These two devices will be able to use a private IP address to communicate with each other. However, any data sent to the internet from either of the other devices will be identified as the same public IP address. Public IP addresses are given by your internet service provider or ISP at your monthly fee. Oh my god. So that would be if you're in America, Xfinity, T-Mobile, etc. Maybe Cricket. I don't know. So as more and more devices become connected, it is becoming increasingly harder to get a public address that isn't already in use. That's why we also use IPv6. Right now we have IPv4, which is probably everybody's using a lot. Everybody has a lot of devices, so now it's getting overflow. That's why we invented IPv6. It's going to be talking about it right now. For example, Cisco, an industry giant in the world of networking, estimated that there would be approximately 50 billion devices connected on the internet by the end of 2021. Enter IP address version. So far, we have only discussed one version of the Internet Protocol addressing scheme known as IPv4. We're going to be really focusing on IPv4 right now instead of IPv6 because everything still uses IPv4, so we're still good on that. Which is a number system of 2 to the power of 32 IP addresses. Now, if you don't know what's 2 to the power of 32, just go back on algebra, I guess. I don't know how older you are, but you should know powers, I hope. So you can see why there is such a shortage. IPv6 is a new iteration of the Internet Protocol addressing the scheme to help tackle this issue. Although it is seemingly, I need to go back to English apparently, seemingly more daunting, it boasts a few benefits. Supports up to 2 to the power 128 of IP addresses, 340 trillion plus, resolving the issues faced by the IPv4. More efficient due to new methodologies. The screenshot below compares both IPv6 and IPv4. Now, I can see IPv6 means seems very daunting at first, but you're gonna get used to it. But IPv4 is what we're gonna be focusing on because IPv6 still has the same kind of concept. And yeah, this is gonna show MAC addresses. Devices on the network will have a physical network interface, which is a microchip board found on the device motherboard. Now, if you open your laptop or whatever, there should be a microchip uh, embedded there with your MAC address, and that you can actually spoof it, but that's how people know who they're talking to. So yeah, this network interface is assigned to a unique address at the factory it was built at, called a MAC, Media Access Control Address. Now the MAC address is a 12-character hexadecimal number, a base 16 number system used in computing to represent numbers, split into two and separated by a colon. These columns are considered separators. For example, A4, okay, I'm not going to read it, you can read it. The first six characters represent the companies that made the network. So this, if you can see here, is the numbers that made the network, or made the MAC address. And the last six are unique numbers. So technically, everybody should have different unique numbers, but there are times, very unique times. Usually, when big companies buy a bunch of computers, maybe have this problem, but sometimes uh, they will have the exact same MAC address on the same network or the Wi-Fi, and that can cause serious problems. What they usually do is replace them. It's very rare though, and especially like for a day-to-day user. So you get a laptop, your family gets a laptop. It it's almost impossible for that to happen. But if it does, you contact the company that you bought the computer from, be like, it's the same MAC address, and yeah, there is ways to resolve this. However, an interesting thing with MAC addresses is that they can be faked or spoofed in a process known as spoofing. This spoofing occurs when a network device pretends to be identified as another using its MAC address. When this occurs, it can often break poorly implemented security designs that assume that the device talking on a network are trustworthy. Take the following scenario. A firewall is configured to allow any communication going to and from the MAC address of the administrator. If a device were to pretend or spoof this MAC address, the firewall would not think that it's receiving communication from the administrator when it isn't. Now, usually they would check for the MAC address and then probably a password or something like that, or the account. So that would be more secure, but yeah. Places such as cafes, coffee shops, and hotels alike often use MAC address control when using guest or public Wi-Fi. This configuration could offer better services, example, faster connections for a price if you're willing to pay the fee per device. The interactive lab attached to this task have been made replicate to this scenario. Practical? Okay. Now we're gonna, I think there's a thing, no. The interactive lab simulates a hotel, wait, is there? Where is the, oh, your website. Okay, so this is basically describing this. Okay, before we do that though, we are gonna look at this. Where are the questions? Right here. What does IP stand for? That would be Internet Protocol. There you go. What is each section of an IP address called? That would be an octet. How many sections? This should be 4. 10, 0, 10, 0, yep, 4. What does the term MAC stand for? That would be Media Access Control. And now we need to find the flag. So as you see, Alice here is probably an admin, and its MAC address is this. So because the firewall of the internet is can identify this MAC address, it's sending through the packets, and the other end is receiving it. Now, Bob here can't do the same thing because its MAC address is not allowed through this internet or firewall. So what we can do is, can we copy this? I hope I can. Is we can change it like that, enter, and we can, wait a minute, if it does work, then we need to cut this one maybe. No? Mm, oh wait, oh request site, there we go, I was like, there you go. And you can copy this as a flag. And as you see now, we can set packets too if you request a site. And there we go. Now ping ISMP. You can close this now from down here. Okay. So ping is one of the most fundamental network tools available to us. Ping uses ISMP Ethernet Control Message Protocol package to determine performance of a connection between devices. For example, if the connection exists or is reliable. Now you can also ping like Google right now, and it's fine unless you do too much, which that can cause a DDoS attack. But they have actually good protocols and whatever. Anyways, this is the time when you ping it, you send a packet and it sends you back, and this is the time between that. The time for the ISP packets traveling between devices is measured by ping. This is a screenshot below. This measuring is done using ISMP's echo packet and the ISMP's echo reply from target device. Pings can be performed against devices on a network, such as your home network or resources like websites. This tool can be easily used and comes instead of operating systems OSS, such as Linux and Windows. The syntax to a simple ping is ping IP address or website URL. Let's see the action. See this action in the screenshot below. Now, yeah, it's basically gonna do this. Let me open the website. Okay. What ping protocol? So here we're pinging devices that are on the private address 192.168.102.54. Ping informs us that we have a 6 ISMP packet of all which were received with an average of 4.16 milliseconds. Now you're going to do the same thing to ping the address 888, 8.8.8.8, website stacks. What protocol ping does it use? So IP address, you can put it up here. I can't type it. No, I can't. Okay, 8.8.8.8. And this seems to be a Linux terminal. If you're used to that, user, yeah. And you can see here the time response back. What protocol does ping use? That should be ISMP. What is the syntax to ping 10.0.10.0.10.0? That should be ping 10. Oh, like that. If you want to ping that. What flag? This should be the flag we got. And I should be able to copy paste. Yeah. Okay, if you have any questions, again, you can comment, email me, find me, whatever, and I'll explain to you more thoroughly, or I'll make a video actually, so everybody knows about it. And yeah, that should be it for this video. And yeah, I hope you guys found this informational and actually learned something. Again, if you have any questions, reach out to me. And I hope you guys have a good one. Thank you.